Hello, my amazing students. This is Mrs. A, and I'm trying to do videos for Chapter 5 of College Algebra. So right now we're talking about inverse functions in Chapter 5.1, and I've written a problem up here on the board, and we're just supposed to find the inverse relation. And remember, when we have inverse functions, the points or the coordinates actually switch around. So the answer to this problem would just be negative 10, 6 would be the point that's going to be on the inverse relation to this one. And then negative 9, 6, and then negative 8, 4, and negative 7, 2. And that's it on that one. Okay, so the second problem, now these, what I'm doing is I'm going through the problems that are at the end of your PowerPoint slides because a lot of these I don't have time to go through in class, and also because these are actually from your test bank that I test you from. So the second one is just 11, 9 and negative 9, 18 and 1, 19. And again, this is the second problem. So we're just going to switch the coordinates around, and the inverse relation would be 9, 11, 18, negative 9, and 19, 1. And that's it for that one. So we're going to go on to the second one, and it says find the equation of the inverse relation. So take this one off my board, and we're going to do x is y minus 5y squared. So that's the first one. This is number 3 in the back of your PowerPoint slides. And when we're getting the inverse, we first switch the x and the y. So we're going to change out the x and make it a y, and then x minus 5x squared. So that would be step 1. And then step 2, my lights just went off. Can you still see? Step 2 will be to solve for y. Well, it already is solved for y because we started out with just the x's. So it's already solved for y, and that one should be the inverse, and it is. That's the inverse answer because I've got the answers on my screen, and I've got to turn the lights back on. All right, so now we're back here with number 5 on the back of the PowerPoint, and we have 3 absolute value of y. Now, we know that absolute value functions are V-shapes. Now, this one is actually x equals. Now, we're used to seeing vertical functions, so we're used to seeing y as 3 times the absolute value of x, which would have been up like that. That's going to be the inverse function of this one. So this one is going to have a stretch of 3, and it's going to go horizontally. So if I plugged in a couple of points, okay, so this one is the inverse function. This is the original function. So if I plug in a couple of points and I plug in a y of 0, then I'm going to get out an x of 0. If I plug in a y of 1, then I'm going to get out an x of 3. If I plug in a y of negative 1, then the absolute value will make it a positive 1, and I'll still get out a 3. So my V shape is going to the right. I've got a 0, 0, and a 1, 2, 3, 1, and a 1, 2, 3, negative 1, and my V shape, which is my original function, is going to go in that direction. This, when I've switched the x and the y, that is the inverse function, and it's going to be going up in this direction. And remember, to get the inverse function, all I have to do is turn these points around. So 0, 0, 1, 3, negative 1, 3 will be the points on this one. So I'm going to 1, 3, and negative 1, 3, and it's going up in that direction. Remember that our inverse functions are always going to reflect across this identity line. Okay, so here's my line that it's reflecting across, and I hope you can see that's my inverse function there. Okay, and My solid function is the original function, and here is that reflection line. This y is equal to x line. All inverse functions will reflect over that line. So let's go to number 6. And number 6 is also a graph. And we're to do the same thing. Okay, so we're going to graph y is 5x. Okay, and that's the original function. And y is 5x is just a line in slope-intercept form, but the slope is 5 and the y-intercept is 0. So y is mx plus b, right? So we're going to go 1, 2, 3, 4, 5. And so 1, 5 will be a point. So 1, 5 would be a point if I put it in my x, y grid. Okay? And then if I plugged in a 2, I'd go up to a 10. If I plug in a 0, I get a 0. If I plug in a negative 1, I get a negative 5. Okay, so this is just a line of slope 5 going through 0, 0. The inverse, which I'm going to graph in dotted line, is going to be these points reflected. Okay, so 5, 1 will be 1, 2, 3, 4, 5, 1. And then 2, 10 is going to become 10, 2. So way over here to 10 and then up 2 and 0, 0. And then negative 1, negative 5 flips around and becomes negative 5, 1. So I go over here to negative 5, negative 1, negative 1. And then I draw my dotted line. Okay, and these two lines, again, are reflecting across this one. I had to just get a different color to do the reflecting line so that you can see it. How about red? We'll see if the red works. Okay, so the reflecting line will be in red because I want you to see it, but I don't want you to get it confused with the graph there. So can you see how the reflection is occurring across that red line there? That is the number 6 in the back of the PowerPoint. Okay, and number 7 in the back says prove that the function f is 1 to 1. So we have f of x is equal to x cubed minus 4. And we're trying to prove that that is 1 to 1. Okay, now if you look back at the PowerPoint, you will see what I'm going to show you in just a minute. Okay, so this slide right here is 1 to 1 functions. And a function f is 1 to 1 if different inputs have different outputs. That is, if a does not equal to b, then the function at a cannot equal to the function at b, or a function f is 1 to 1 if when the outputs are the same, the inputs are the same. That is, if the function of a is equal to function of b, then that means that a must be equal to b. So what we're going to do is we're going to take this definition and use it to prove. Okay, so now in this one, they gave us a 1 to 1. So basically, if the inverse of function is also a function, it is named f of negative 1, and it's read f inverse. Okay, so basically, remember, this is just a definition of the inverse function. And remember, this is very important because it's not part of this problem, but f inverse does not mean the reciprocal. It means that it is the inverse of the function. Okay, so these are qualifications of 1 to 1 functions and their inverses. This is also very important from the PowerPoint. And then we will go back and work that problem. Okay, so I have proven this on the board for you. So basically, this was our function. So basically, remember, it's 1 to 1 if f of a is equal to f of b. That means necessarily that a is equal to b. So that means it's 1 to 1. So I started out by saying, okay, if this is my function, then f of a is a cubed minus 4, and f of b is b cubed minus 4. So basically, if f of a is equal to f of b, then I have this over here must be true, which when I add the 4 to both sides gives me an a cubed is equal to a b cubed, which means necessarily that a is equal to b, and they are 1 to 1. Okay, so the next problem was proving that the function f is not 1 to 1. And the function that they have here for this one is f of x is absolute value of x minus 2. Okay, now absolute value of x is a v-shaped function dropped down to. Okay, we should be able to see it in our brain, and we should know it's not 1 to 1 because it is a v-shape drop down to, like this. All right, and a 1 to 1 function passes the horizontal line test also. And this one does not pass the horizontal line test because it's hitting it twice. But let's do it. Let's prove it. Let's don't just show it. Let's prove it. So we're going to do the proof the same way we did the other one. And we're going to say f of a is equal to absolute value of a minus 2. And f of b is equal to absolute value of b minus 2. Now, if f of a is equal to f of b, then absolute value of a minus 2 must be equal to absolute value of b minus 2. When I add 2 to both sides, then I get absolute value of a is equal to absolute value of b. And that does not mean that a is equal to b. That means that a is equal to plus or minus b. Therefore, it is not 1 to 1 because I can't get down legitimately to just a must equal b. A has two options, plus or minus b. Therefore, it is not a 1 to 1 function. Okay, so let's look at the next one. So now we're going to do number 9 on the back of the PowerPoint, and we got 0.5 to the x. Now remember, that's the same thing as 1/2 to the x, and 1/2 to the x is the same thing as 1. So basically, this is going to be 2 to the negative x. 2 to the negative x is the same thing as 1/2 to the x, okay, which ends up being the same thing as 1/2. I didn't have a parenthesis and I should have, okay. So they're the same thing. Now, what do we know about 2 to the negative x? Shouldn't it be graphed as a reflection across the y-axis because the negative is up there in the exponent? So this one should be the same function, but it should come down through 0, 1, and go off that direction, and that is indeed how it is graphed. Okay, so basically I have the graph here. So here you can see it a little bit more neatly graphed, and that one is a 1 to 1 function also. Okay, so number 10 is just asking us if this is a 1 to 1 function. Well, when we look at it, we can see that it passes the vertical line test, and we can draw an infinite number of lines vertically, but it also passes the horizontal line test. And so this one is 1 to 1. Okay, so then it says yes, it is 1 to 1. So now we look at the next one, and it says determine whether the function is 1 to 1 by graphing and using the horizontal line test. Now I'm about to graph this one on the board, but let's think about what it looks like. Okay, we've got 9 minus x squared underneath the square root. Okay, so the square root means that this thing is going to have a limited domain, and its domain is going to be when what is underneath the radical is greater than or equal to 0. So let's graph this one on the board. Okay, so I'm going to start off with a point grid. I know that what's underneath here must be greater than or equal to 0, or I will have an imaginary function. So I'm going to say 9 minus x squared must be greater than or equal to 0, which means that negative x squared must be greater than or equal to subtracting 9 from both sides, okay? And then I'm just going to divide both sides by a negative, but what happens when I do that? I need to flip this sign around, and I get x squared is less than or equal to 9, or x is less than or equal to, when we're doing this one, we're going to have plus or minus 3. So we should be going in between those two numbers. All right, so now we're going to plug in some points just to see what it looks like. Okay, so we have x and our y, and we're going to plug in a few points. So let's let x be 0 because it's in this range. If we let x be 0, then we're going to get a 9, and the square root of 9 is a 3. Right? If we let x be 1, then we're going to have 9 minus 1 underneath the radical, which will be the square root of 8. And if we put in a negative 1, then wouldn't we also have the square root of 8? Okay, because the negative is going to square out, we'll have the square root of 8. Not 1 to 1, is it? Right? So then if we plugged in a 2, we'd subtract the 2 squared, which would be square root of 5. And if we plugged in a negative 2, it would also be the square root of 5, not 1 to 1. Okay? And then, so let's graph this. We got 1, 2, 3, because we're told to graph it. And then square root of 8 is going to be slightly less than 9. It's going to be 2 point something. But we'll just say that's going to be 1 and somewhere up there. Negative 1 somewhere up there. 2, square root of 5 is a little bit over 2. So at 2, we're going to get something a little bit over 2. And then at negative 2, we're going to get something a little over 2. And then when we plug in a 3, it goes to 0, doesn't it? So when we plug in a 3, it's going to go to 0. And a 3, it's going to go to 0. And if we plug in a 4, then all of a sudden it's imaginary. So this thing looks something like this. All right, the square root looks something like that. Definitely not 1 to 1, okay, because we cannot pass that horizontal line test. Okay, so the next one we're going to do is the square root of x plus 2. Okay, so we have the square root of x plus 2. Okay, oops, the whole thing is underneath the radical like that. All right, so now we're going to graph it and tell whether it is 1 to 1. And this one you should recognize. It's the square root of x function shifted over 2 steps to the left. So I'm not going to spend a lot of time on that one because I know exactly what it looks like. When x is 0, we get the square root of 2, which is about 1.4. So 1.4 is our y-intercept, and this thing is going to go off in that direction. No mystery on a square root function. And that one is, yes, it is a 1 to 1 function. Okay, and then we're going to find the inverse in number 13 and 14. We're going to find the inverse of some functions. So the first one on number 13 is f of x is equal to the cubic root of x minus 7. Okay, so we're finding the inverse, which means we're going to switch the x and the y. So this one is the y, so we're going to make it the x. We're going to say cubic root of, and then this one is going to be a y minus 7. Then we resolve for y. Okay, so we're going to cube both sides. So we cube, and then we get x cubed is equal to, and then the cube of the cube root is going to leave me a y minus 7, and then solving for the y, getting the y by itself, I'm going to get the 7's going to go over here, and then I'm going to turn it all around and get y as x cubed plus 7 as the inverse function, and that is correct because I have the answers in front of me. So let me see if I can show you that whole board there. Okay, so that one was number 13 in the back of the PowerPoint. And then number 14 is a line. Okay, so number 14 is f of x is equal to x plus 6. Okay, so now we have a line and we're going to find its inverse. So we switch the x and the y. So x is y plus 6. We get the y by itself. X minus 6 is y, or y is x minus 6. And then we take the y out and we say f of negative 1 of x, because it is the inverse to the original function. And that is correct. Okay, so number 15, it says determine whether the given function is 1 to 1. If it is 1 to 1, find the formula of the inverse. Okay, so the first one that they give us is 5x minus 3. It's a rational function. Okay, so f of x is 5x plus 3 over 5x plus 7. Okay, so that is the original function. And first of all, we have to decide, is it 1 to 1? Okay, and it is 1 to 1. And these, when we graph them, remember they have asymptotes. So this one has a vertical asymptote. Okay, we plug in the vertical asymptote. We say, okay, what makes this go to 0? And it would be negative 7/5, right? If I had a negative 7/5 in there, it would go to 0. So negative 7/5 is a little bit over 1. So that will be our asymptote right there. Okay, and then we have a 0 where the numerator goes to 0. And that's going to be at negative 3/5 that we will have a 0. So maybe right about there we would have a 0, which means a crossing. And we have a horizontal asymptote. Since these two powers are the same, then our horizontal asymptote is going to be the coefficient 5 divided by 5, which is 1. So we have a horizontal asymptote of 1. So this is a good review for our rational functions that we've done. So horizontal asymptote is y is equal to 1. And so now we're ready to graph it and see what it looks like. Since we have a 0 here, I'm thinking this one's going to come up and approach. Now, I'm going to check out, what is my y-intercept? When I plug in x is 0, then I'm going to get a 3/7 as my y-intercept, which, well, that looks like that could be a 3/7, because remember this is a 1. So that makes sense and verifies that I've graphed it correctly. But remember, our graph should then come in here at positive infinity and go there. And I can verify that just by plugging in a point. So let's plug in a negative 2. And if we get something greater than 1, then we'll know that we're accurate. So let's plug in a 2, and we're going to get 10 plus 3 is 13 on the top. Plug in a 2 down there, and we're going to get 17 on the bottom. And we'll set 13 over 17. Oh, negative 2. I'm at negative 2, not positive 2. Okay, this one just verifies that the positive 2 is right. And it should be at positive 2, it should be less than 1. But now over here, I'm plugging in negative 2, which I didn't do. So negative 10 plus 3 is a negative 7. And a negative 10 plus 7 is a negative 3. And when I simplify, I get 7/3, which is over 1. It's about 2 1/3, right? So when I'm over here at negative 2, I am up over that asymptote. And that makes sense. Okay, so my graph is correct. And remember, with these rational functions, they're 1 to 1. And they've got this one is always climbing. And then this one is always climbing as it approaches. And then you've got the asymptote. So their domain is not all real numbers. But they do have a 1 to 1 characteristic. So now we're going to take this function and find its inverse. So let's erase the graph so I have a little bit of room to work. So now we're going to switch the x and y. So we're going to say x is 5y plus 3 over 5y plus 7. okay? And now I'm going to cross multiply. And when I cross multiply, I'm going to just make that a 1 here. And then I'm going to say this is equal to, when I cross multiply, x times 5y plus 7. And then that's going to have to equal, I'm going to extend this a little bit to the right so I have more board. Okay, that's going to equal the other direction, which is just 5y plus 3. Okay, so remember, I'm trying to get, now that I've switched the x and y, I'm trying to get the y on one side by itself. So I need to multiply this out and get all of my y's on one side. So this is going to be a 5xy, and then plus a 7x equals to a 5y plus a 3. Okay, so now, I'm just making sure you can see the board over here. Okay, so now I'm going to get all my y's on one side. So 5xy minus 5y. And then I'm going to get my x over here. So it's a negative 7x plus 3. And then I can factor out my y. So I'm going to go to y times 5x minus 5 on the left. Okay, and then on the right, I've got a negative 7x plus 3. So now, can I get my y isolated by just dividing both sides by the 5x minus 5, which is what I'm going to do. So my answer should be y equals negative 7x plus 3 over 5x minus 5. Okay, so now I've got my y equals over here. So now all I'm going to do is change that y into an f of negative 1, because this is now my inverse function. So I get f of negative 1 of x, indicating it's the inverse of the original function. And we are correct, because I have the answers in front of me. Okay, so that's kind of a big process. We had to what? First determine that it was 1-to-1. By just looking at it, graphing it, looking at it, and then switching our x and y variables, and then resolving for y, and then turning the y into an f of negative 1 of x. Okay, so that was number 15, and number 16 is going to be very much like it, so I'm not going to do that one. I'm going to move on to number 17, which says the graph of a 1-to-1 function is given. Sketch the graph of the inverse using a dashed line for the inverse. Okay, now this one's pretty easy because it's linear. Number 17 is a line, and it's got 0, negative 1, and another point is 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. So that is the original function. Okay, now we're going to have the inverse function is going to have the points switch. So if this one was 1, I'm with 0, negative 1, okay, then 0, negative 1 is going to turn into negative 1, 0 on the inverse graph. So negative 1, 0 would be right there, okay, and then this one is a 5, 3. So the 5, 3 is going to turn into 3, 5, which is 3, 1, 2, 3, 4, 5. Okay, so we're going to end up with a point here and going down here somewhere. Okay, so they're going to cross somewhere down there, and there are the two lines. So basically, can you see that line of reflection there? The y is equal to x-axis has a slope of, the y is equal to x line has a slope of 1 and goes through 0, 0, and that will be the line that the two reflect across. Okay, so on 18, we are given a cubic equation, and this cubic looks like it goes through 0, 1. So I'm looking at 18 on the slides in the back, and negative 1, 1. And let's get another point that looks exact. It looks like it's -2, negative 1, 2, 3, 4, 5, 6, 7, 8. We'll say this is -2, 8. Okay, -2, -8, excuse me. And this one is -1, 0. And then this one, maybe this is -7. I bet you it is. It's hard to tell. And then this one up here is 0, 1. And then we go through maybe 2, 1, 2. Okay, so 1, 2 looks like it's a point. All right, so that's enough. We know what we're doing. We've got a cubic, so cubics have a squiggle in the middle. And we're supposed to graph the inverse of this function. So basically, I can take each one of these points, and so I know it's going to be -7, -2 when I flip that point around, and then 0, -1, and then 1, 0, and then 2, 1. Okay, remember, I should see the reflection happening across this y is equal to x line. So let's plug in those points. -7, -2. So -7, -2 is somewhere about there. 0, -1 would be about there. Okay, and then 1, 0, and then 2, 1. Okay, so basically it's going to come like this from over here, and it's going to squiggle this way, and it should go out in that direction. So that should be the inverse function. And it is. Okay, so I've got a picture that's graphed a little bit better. That's the answer that they give you on the PowerPoint. All right, so now we're given a function and its inverse, and we are to prove that they are actually inverses of each other. And the way to do this is to compose the two functions together. So I'm going to take f of the inverse of f and compose it. I should get an x if this is true. So I'm going to take this function as my base function, x plus 2 over 9, and then I'm going to take out the x, and I'm going to slide in the 9x minus 2. 9x minus 2 is going to slide in there. So then I got 9x minus 2 plus 2 is 9x, and then I divide by the 9 on the bottom, and I end up with an x. Okay, so it works in that direction. So then I need to do the same thing, but now I'm going to take f of -1. So f of -1 of x, and I'm going to compose it with f of x. So I'm starting with the f of -1 as my base function. Okay, so now when I do that, I'm going to end up with my base function being this one, 9x minus 2, so 9x minus 2. And then in place of the x, I should have written that a little bit bigger, 9x minus 2, a little bit more spread out. So now in place of the x, I'm going to take out the x, and I'm going to put in my original function, which is x plus 2 over 9. So x plus 2 over 9, and then the 9's are going to cancel each other out, and I get x plus 2 minus 2, which is x. And since I got an x in both directions, they are indeed inverse functions of each other. Okay, so basically they're showing on here, they're showing it very neatly. Mine is not so neat, but they're showing it very neatly done both directions. And since you get an x both directions, f of -1 of x and f of -1 of x they are inverse functions. All right, so now we're going to skip to number 22 because many of these are the same general principle. Y is equal to the square root of x minus 4. We are to graph the original function and its inverse. So I know that the original function is a square root function moved 4 steps to the right. So 1, 2, 3, 4. It's going to go off in that direction. That's what square root functions do. Its inverse, and this is a one-to-one function, so it should have an inverse. Its inverse should, now remember this point right here, if I plug in a 5, I get out a 1. So 5, 1 is a point, and 4, 0 is a point. So I can use those 2 points and switch them around. So 0, 4 would be a point, and 1, 5 would be a point. And so this one is going to go off in this direction as the inverse, okay? And that's exactly what they show you, except they dashed this line because they told us to put the inverse as dashed, okay? Now we're going to talk about domain and range. Remember when we're doing these functions with their inverses, the domain of the original function becomes the range of the inverse function, and vice versa. So it says find the domain and the range of the inverse function of the given function. So here we have 23, and the original function is f of x is x cubed plus 5. Okay, now x cubed plus 5 has no limitations in any direction. In fact, when I graph it, it's going to be my basic cubed function moved up 5 steps. So 1, 2, 3, 4, 5, and it's going to have its little anchor point there, and it's going to go like this, okay? And it is all real numbers in both directions. So guess what? The inverse function will also be all real numbers in both directions, which is the correct answer. Domain and range, all real numbers, okay? But let's do the same thing with number 24. And number 24 is not unlimited. It is f of x is equal to the square root of x minus 9. So let's graph the original function and think about what its domain and range is. So this is our square root function moved 9 steps to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where the function starts. And then it's going off in the square root fashion there. And so its domain of the original function would be x can be greater than or equal to 9, which would be bracket, because a 0 would be okay. I mean, a 9 would make this 0. So we've got 9 to positive infinity is the domain. Okay, what about its range? The range is what y can be, and the y is going to be all positive y's or 0. So we would say the range of the original function is going to be 0 to positive infinity, right? It can't go down here. So that would be our domain and range of our original function there. So since we know that the domain and the range of the new function should switch, then for our new function, we're going to take the domain and we're going to put the range, because that should be the range of the inverse function. And we're going to take what was the range of the original, and we're going to make it the domain. Okay, because we actually switched the axes. Okay, and so on the answers, this one is listed as the domain and this one is listed as the range, just like that. Okay, so that is the end of our 5.1 PowerPoint, and I hope that this has helped you in understanding a little bit more about inverse functions. And remember that those problems that I went through with you are from the test bank. So your test, when I create these little questions at the end of a PowerPoint, what I basically do is take a sample of all the problems that are on your test bank. And so if you prepare by watching the video and understanding it, you have a real good chance of doing well on the 5.1 section of the test. And this is Mrs. A, and may God bless your day.